signed integers, positive numbers and 0 can be represented by unsigned n-digit numbers. We need a representation now for negative numbers. So when you are writing a number in 2's complement, it's going to be, you keep going until you reach the first one, then you complement the rest. So this is going to be a signed 2's complement representation for any number. Okay, to represent now a signed number, the S is going to be 1 bit, and then you will have 7 bits. So this is a sign, 1 bit, and here you will have 7 bits in case of course, 8-bit registers. So this is A0, A1, A2, A3, A4, A5, A6, A7. Okay, here 7, it will be the sign. So starting from A0 to A6 will have the magnitude of the number, and the S will have the sign. Okay, so when you read S and it is equal to 0, this will tell me that the number is positive. When you read S equal to 1, which is the most significant bit, okay, so this is the most significant bit, this is the least significant bit. If S is equal to 1, this is a negative number. Now, for AI equal to 0 or 1, this represents the magnitude in some form. So starting from here till the number that comes after the sign, this is referred to as the magnitude, and the S is the sign. Okay? Since computers only use binary numbers, okay, so we have to write the positive number and the negative number also in binary. So this is why we use this representation, where S is the sign and the rest of the digits are the magnitude. Okay, so let's say now you want to write in signed magnitude. So you have two ways of writing signed numbers. You could either write signed magnitude, which where you have 7 digits for the magnitude and 1 bit for the sign. Okay, the sign complement is, this is where you do the 1's complement, then you add 1 to it, so it gives you the 2's complement. So I will give an example so you understand the difference between the two. I will write number 9 in signed magnitude. I'll start first with the number 9 unsigned. So it's going to be 0, 0, 0, 0, 1, 0, 0, 1. This is unsigned. Okay? How about signed magnitude? Okay, it's going to be 1 for the sign, and the rest will be the same. Okay, so this is signed magnitude. How about in 2's complement? You keep going until you reach the first one, then you complement the rest. So this is 2's complement. So this is 9 unsigned, this is minus 9, and this is also minus 9, but in 2's complement. You see the difference in the representation? Any question?
Doctor, so we don't complement the signed magnitude 1 at first?
No, the 2's complement, you complement the unsigned, of course. Okay.
Please, في كده جون شوية سريع لأنه I got disconnected وما لحقت.
Okay, so I will repeat them in another example. Let's say you are writing number 1010. What is this number to you?
10.
That's number 10, okay? So I write it in 8 bits. So this is the number 10 unsigned, okay? How about if you want to write the number now in 2's complement? You keep going until you reach the first one, then you complement the rest. So this is number minus 10 in 2's complement. Okay? What if you want to write it in signed magnitude? Who can help?
We put 1 and then we copy the first one.
So you put 1 for the sign and the rest will remain the same. So this is 7-bit for the magnitude and this is for the sign. So this is the S and this is the magnitude. Clear? So again, this is minus 10, but in sign magnitude. Okay, any question?
Okay, thank you, doctor.
Okay, so I want someone to tell me what is this number, please. It is number 9.
9.
Okay, but we won't be using 4 bits. Okay, we will be using 8 bits. We will always be using 8 bits in the assignment and in the exam. And later in the other course that comes after this, the computer architecture, we will be using 32 bits and 64 bits and 16. So never 5 or 7, these are not acceptable. We will be using 8-bit registers because this is the actual size of registers. We have 8-bit, 16-bit, 32 bits, 64 bits. So these are the size of registers. Okay, so I will be using 8-bit registers in your course. Okay, so this is 1001. It will give you the 9, but writing it in 8 bits is going to be 00001001. So this is plus 9. You agree? Okay. If you look at this number now, the first question that should come to your mind, if I ask you, what is this number? You should tell me, is it signed or unsigned? Right? Does it make a difference if it is signed or unsigned when you represent it?
Doctor, I have a question.
Yes.
When we say the complement, we keep writing until the first one, then we write the complement of each bit. مظبوط?
Yes.
Okay, the signed. شو فرقت? It's
You
like the first one.
You start working this in the 2's complement from the positive number. You don't do it from sign magnitude. It has to be done from the positive number, which does not have a sign here. Okay, so you always do the 2's complement from the unsigned number with no sign.
Okay, I'm talking about the example هيدا اللي تحت.
Yes, the example that we have, the first number that you have here, it is number, let me change to a point. This is number 10. Okay, it is unsigned. If you want to write it in 2's complement, you keep going until you reach the first one, so 0, 1. Now that you reach the first one, you complement the rest. This is minus 10. Here what happened? The number all remains
unsigned one.
بدل هو ذاته the same like the unsigned, but you put a 1 for the sign. This is minus 10.
Let's say the unsigned ended with 1 already.
If this is a 1, yes, a very good question. You are saying, so let me erase this. You are saying, what if the number started with a 1, right?
The unsigned number.
Yes, I got you. So this is a number. And you told me, or I gave you the question, and I said this is unsigned. Who can answer, Anthony? It's a very good question.
This is wrong. Unsigned should be a 0 at first, no?
No, he's saying, what if this is the number? And this is a number that is unsigned. So what do you think?
I add a 1 بالآخر برجع.
No, you cannot change the register. I want you to think of registers. Registers are hardware. They are actually hardware registers. They can store up to 8. You cannot add anything to them. They can fit only 8 bits. So whenever you get the idea of adding a bit to a register, that's not feasible. It can fit 8. Okay? It's hardware. Register is a hardware.
So we changed the last 0 to 1.
No, you are changing the number.
It stays the same.
Perfect. It stays the same. And in unsigned, we usually use the 8 bits, the whole 8 bits, okay, to represent the number. This is the difference between unsigned and signed. In unsigned, Anthony, I use the 8 bits. In signed numbers, I use 7 bits for the magnitude and 1 bit for the sign. Clear?
Okay, but we write the same number in this case.
Yes, but it is
Zero.
unsigned. It is unsigned. So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 4, 2 to the 5, 2 to the 7. You add them, you will get your value.
دكتور أنا بعد نضيع بين signed و unsigned.
Been signed or unsigned. Okay. So what can we do about that? We will try to write one more example so I make it clearer. Okay. The first question that I should tell you from the very beginning, I should say that this number is signed or unsigned. I should be clear about it. Okay. If I said the number is unsigned, okay, it means I can use 8 bits for the representation, the whole 8 bits. Okay? If I said the number is signed, then I am using 7 bits only and 1 bit for the sign. So what is the biggest number I could write in 8 bits? It's 255. Anything greater than 255 will be an overflow. Here, the biggest number I could write in the sign is 127. After that, it's an overflow. You got the difference?
Yes. وإذا كانت 1 يعني sign positive إذا كانت 0 negative.
Exactly. This is in the signed, right? This is in the signed.
Yes.
Okay. In the unsigned, you use 8 bits.
Okay,
In the
thank you.
signed, you use 7 bits. 1 bit, which is the most significant bit, will be dedicated to the sign only. So you cannot use it in the representation of the number. Okay, whereas in the unsigned, you could use all the 8 bits for it. So you could go up to 255 because the bit that you see here is 2 to the 7, remember? Which is 128. So 127, if you add to it 128, doesn't give you 255? Okay, so I could add to the number. It's not, I do not stop only at 127 in 8 bits. I can go up to 255 in the
Yes.
numbers I could represent. Okay?
دكتور بس بالunsigned حتى لو the last one is 1, it's still unsigned.
Yes. This is unsigned. So this one in the unsigned does not tell me anything about the sign. So this number 1011011,
Yeah.
this
It
number
is 8 bits and
is 8
unsigned.
bits. So this is 2 to the 0, 2 to the 1, 2 to the 2. You see what I mean? And this is 2 to the 7. It's included in the number. Okay, so it is in the number. You add these all up, you will get the number in decimal. Okay? Whereas if this is a signed number, this is going to be minus a value. So it makes a big difference. Okay? Clear?
دكتور
Yes.
شو بنعمل بالأوفرفلو؟ أول مرة حتصير معنا أوفرفلو.
We will today explain overflow. Okay?
Okay.
I gave you only one case of it where you have an 8-bit and the number is greater than 255, implies overflow. Okay? Clear? I gave you now one case. When do you have a case of an overflow if the number is signed? What do you think? Signed.
128.
127 actually, right? Greater than 127. You agree? Okay. So I want you to look at this. This is number 3. I'm giving you examples so I make sure you understand. But I have to repeat my remark that we will be using 8 bits, not 3 or 4 or 7. Okay, we will be using 8-bit registers. Okay, we start with number plus 3. If it is sign magnitude, the sign will be a plus, let's say 0, and then you will have the 3, which is 1, 1. In 1's complement, okay, you just complement it, okay, by adding in 2's complement, you will have to, what's this? In 2's complement, so let's say you have 0, 1 second. You have 0, 1, 1. You keep going until you reach the first one, then you complement the rest. Okay? Right? So minus 3 will be this. You see? So plus 3 in 2's complement, in 1's complement, and sign magnitude won't differ because it is plus. The same will do for the +2, +1, so no problem. Where do you start to notice the change? In the minus representation. If it is minus representation here, so the 1 is going to be 0, 0, 1. How do you write -1 in sign magnitude? What do you think? -1. Anyone, please?
we add 1 على
We
السكند
add
نص سكند في
على الأول.
second
101.
1, 0, 1. So you change the sign, and the magnitude will be copied the same. You agree? Okay. How about -2? You change the sign, and the 1, 0 remain the same. I'm still in sign magnitude. How about -3? You change the 1, and the 1, 1 will remain the same. Okay. Now let's move to 2's complement. How do you do 2's complement for number 2? So it is 0, 1, 0. How do you make it, please, in 2's complement? Anyone?
0, 1, 1.
0, 1, 1. You agree? So this is it. It's -2. Is it clear? But I repeat, you have to practice on 8 bits always. Okay, when adding numbers, the number, if you have a sign in it, so you are actually adding 7 bits and the sign. Okay? And the biggest number you could represent in sign magnitude is -27 or +127 when you are working on 8 bits. Okay? If the sign bits were the same for the both numbers, the sign of the result is different and overflow will occur. So this is another case that you should be careful about. When do you get an overflow? You are adding 2 positive numbers, so add 2 positive numbers, and the answer that you get, so plus positive, and you get a negative answer, that's wrong. It means I have an overflow. How about when you have 2 negative numbers, so a negative number plus a negative number, and the result will give you a positive number? What does this mean? Overflow. Okay? So you got a wrong answer. Overflow is when adding 2 positive numbers, you get a negative number. Adding 2 negative numbers and you get a positive answer, this will give you an overflow. Okay? The sign of the result is computed actually in step 1 when you have 2 different numbers, okay? In 2 same signs, okay? But if you have 2 different signs, you have to use 2's complement. I will repeat the idea. If you have 1 positive number, 1 negative number, and you are adding them, you must use 2's complement when adding. Whereas if you have 2 positive numbers or 2 negative numbers, you can use sign magnitude to do it. I want to explain this chart now, please. I want you to pay attention to what I'm writing. So it is A plus B. This is the first case that we will be doing. Or we can do A minus B. When I am doing A minus B, I'm still using the adder, the full adder. So I don't have a subtractor, I only have an adder. So look what I will do. It's going to be A plus minus B. What can you tell me about the minus B? How do we create the minus B? Anyone? It is the 1's complement plus 1. Do you agree? Does this make sense to you that the negative number is 1's complement plus 1?
Yes.
Because you actually do 1's complement for it and then you add plus 1. Another method will be you keep going until you reach the first one, then you complement the rest. This is a shortcut method. But the actual method that we use is we do 1's complement plus 1. What's the difference between subtracting now and adding? These are the 2 cases. Okay? In the first case, you are adding. In this case, you are adding. And in the second case, so here, I am adding. And in the second case, I am subtracting. Okay? So what do you notice in common? So A is the same. You agree? What about B? B is either a plus or a minus, okay? So either a B or a B bar if you are subtracting. And the carry in is either going to be a 0 or a 1. Okay? So when I am adding the carry in, which is here, let me show you. This is the carry in. It's going to be 0 when I am adding. A will remain A. How about here? What do we have here on this line in the case of addition?
Minus B plus 1.
No, in the case of addition, I am adding this. What do I have here?
B zero.
Is it B bar? Is it B? Look, it's B. In the case of addition, I have A plus B plus 0. What do I have on C0?
0.
What do I have on A0? A0.
A,
Yes. What do I have here?
B0.
Yes. So not B bar, I have B. You agree? I want someone to tell me if I have here a B and I do XOR with a 0, what does this give me? So A XOR 0. This must be, you must know that. A XOR 0, it will give me A. A XOR 1, it will give me A bar. Okay? These identities you must know. So now, if my S is a 0 here, and this is a B0, when I do XOR for them, I get a B0. And this is my A0, and this is 0. Can you see them? Okay? So this is the first. I get now a sum, and a carry in will go to the next full adder. Question, what do I have on the second part now? Here, what do I have? So here I have A, yes,
A1,
A1. This is also going to be
B1, and C1.
B1, right? And C1 I cannot tell because it depends on the previous addition, okay? So S in the case of addition will be 0, in the case of addition. Now here you will have A1, A2, B2, and the carry. And here you will have A3, and this is B3, because this, the S that is going to be 0 here, and here, and here. It's going to be the same because it's from the very beginning here going as a 0. You got the idea? So what am I doing in this figure? I am doing addition, okay, of A plus B plus 0. Okay, did you understand this? Can I start with the subtraction? Any questions? Okay. So let me start with the subtraction. I want you to tell me what will change in this figure when I am doing subtraction. So it is A plus B bar plus 1. Who can help me, please?
B0 plus 1. B bar
والسي بتصير 1.
plus 1.
Start with the S. Start with the S here.
S will be 1.
This will be 1 because I have a carry in of 1. Yes, please. So it's going to be 1 here, and
A
here,
is A and B will be 1.
and here, right? Now, so S will go as 1 to all the XOR input. What else? This will be A0, no change. But this, what will happen now? With B0 XOR 1,
B bar.
it will be B bar. Of course, B0 bar. So I will repeat the identity. If you do B XOR 1, it will give you B bar. Okay? Is it clear? So why am I doing this? Because if I want to use the same adder-subtractor, whether I have A plus B or I have A minus B, it's going to be the same. What will make the difference with the B is, am I using B XOR 1 or B XOR 0? This will make the whole difference with the adder-subtractor if I am adding or subtracting. Okay? Raphael? Any question, guys? No. Okay. So the subtraction can be done by addition of the 2's complement. So it could be A plus B or A minus B. And as we said, if there is S equal to 1, then I am doing A plus B bar plus 1. If S is 0, then I am doing A plus B, so B will pass through the XOR unchanged, and always the carry in will be a 0. So these are the two cases in the adder-subtractor. I want you to look at this example, please, when I am doing addition, okay? Addition in 2's complement. Let's say I am adding these two numbers, okay? One is positive and one is negative. So this is 1101 and this is 0011. Notice, please, here, when you do the addition, this is going to be 0 carry 1, 0 carry 1, 0 carry 1, and 0 carry 1. You need to know that in the addition, when you are doing the 2's complement, the last carry out is discarded. So this one will be discarded, okay? It will not be considered part of the, so this you discard. It will not be part of the answer, okay? Clear? So now what are we doing? I want to subtract. If you are subtracting the A minus B, so you are actually doing A minus B. You want to find the 2's complement of it, so you do also addition, okay, also addition, but you find the 2's complement of B. So this is why here you want to do the 2's complement of this value. You keep going until you reach the first one, then you complement the rest. So this is now what you are seeing here is the 2's complement of 0010. You add them and you get the answer. Okay, clear? At the end, these two operations are addition, no difference. But here you detect the answer. How? You look at the most significant bit. If it is negative, it means that if it is 1, it means that this number is negative. How do you know the original number of it? You keep going until you reach the first one, then you complement the rest. So this is going to be minus 6. Okay? Clear? So what are we really doing here? We are subtracting, in this case, 1101. Who can tell me what is 1101 that you are seeing here in decimal place? What is 1101?
10.
It is 10. Is it?
13.
It is 13 because it is 8, 4, and 1. Right? So this is number 13. Subtract from it number 3. It will give you, let me show you. Okay, so if you are doing a simple...
It will give us 10.
So this is number 13 in unsigned number, and you are subtracting from it minus 3. Okay, so 13 minus 3. This is what we are doing. It is equal to 13 plus minus 3, and it will be equal to 10. Okay? So what is it, please, now? This is number 13. I did not change. But this, I wrote the 2's complement of it. Okay, so the 2's complement of 3 is minus 3. And the answer to me is number 10. Of course, plus 10. How come plus 10? Because 13 is greater than 3. If you have other cases where you are subtracting A minus B and B is bigger, you will get a negative answer. Okay? Now, how do you detect overflows? Overflow, you have many cases. Okay? You have many cases. The first case is, I will list them for you. When you have 8 bits, okay, and you are adding, and the answer is that you are adding to 8 bits, So adding two 8-bits numbers, and you get an answer of 9 bits. Okay, this means that this is an overflow because you cannot fit an additional bit in the register. It fits only 8. Where are you going to put the 9th register? So overflow. Okay, so this is the case where you have an overflow. Who can remember a few minutes ago I told you other cases where you have overflows?
If we add two positive numbers بيطلعنا واحد negative. If we add negative بيطلعنا واحد positive.
Yes, very good. Okay, so if you add two negative numbers and you get a positive answer, overflow. If you add two positive numbers and you get a negative number, overflow. Okay, so these are the cases where you actually can detect an overflow. Detection can be performed by examining the result signs, which should match the sign of the top operand. So if you are adding two positive numbers, you should expect to have a positive answer. But you got a negative answer, then it is an overflow. Okay? Sign number cases with carry n and Cn minus 1, okay, shown for correct result signs. I prepared for you a case, a Word document that has all the cases with all the additions that will give you when do you have actually an overflow, and I will go over them one by one with you, okay? So because here they did not list actually all the cases, so I want to list all the cases. But let me show you please in the Adder-Subtractor. So this is the Adder-Subtractor that you are seeing here inside is this figure. This figure. Okay? So this is the block that you are seeing here. See? This is the block that you are seeing. It is inside this block diagram. Am I clear? Okay, so the figure that we have is here. So you give it the A, you give it the B, and you give it the carry in. Okay? So A, B, let's say A is 4 bits, you will have a 4-bit Adder-Subtractor. Let's say you have 8 bits, you will have an 8-bit Adder-Subtractor. Okay? So look now, please. You have the carry, Cn, and the carry that is before, which Cn minus 1. Okay? If you do XOR for them and you get a 1, it will give you an overflow. Do you remember in XOR, when do we get a 1?
X XOR X bar.
Yes, when do you get a 1 in the output?
If one of them is 1 and the other is 0.
Yes, that's it. So 0, 1, if you do XOR for it, it will give you a 1. And 1 XOR 0, of course, it will give you also a 1. They have to be different, right? So that's the rule of XOR. They are mutually exclusive, if you remember. So C and Cn minus 1 must be different. You XOR them, you get an overflow. Okay? What about the C? C is the last carry. Okay, what is V now? And what is C? These are referred to as status bits. Okay? So I will tell you now what are the status bits available. I have 4 status bits. Okay? The first one is V. It's a 1-bit. Status bit is a 1-bit. It is a 1 if I have an overflow. It is 0 for no overflow. Okay? How about C? What do you think? You tell me. C is, it should be a 1 if I have. Yes, please.
No overflow.
No, think.
Cn equal 1.
A positive number.
No. 1 if you have a carry. 0 for no carry. Now is your turn. And is a status bit. It's going to be 1 if it is negative and 0 if it is positive. Okay? And the last carry you should know about is the Z. The Z. So I have the V overflow status bit, the C if I have a carry, the N if it is negative, and the Z, okay, if it is a 0. If all the answer is a 0. So Z will be a 1, if it will be a 1. If your answer is all zeros. The 8 bits are zeros. Okay, so this is going to be 1 if it is the answer is negative. This is going to be 1 if you have a carry. And V, it's going to be 1 if you have an overflow. What do you call these? These are called status bits, okay? And they really help you to, they really help the CPU with the control. So you are comparing if A is less than B, A less than B, okay? If A is less than B, then N is going to be 1, right? For the answer, I mean, okay? All of these status bits are for the answer of the calculation. You have other arithmetic functions. Okay, I created for you the Adder-Subtractor, but we have others. We have the incrementer, the decrementer. When multiplying by constant, we have the division by constant. So we have many designs that we could use, and we refer to them as contraction. We will do 2 examples in the homework for the using the Adder-Subtractor by contraction. So I minimize it and I get a smaller case. So in contraction, let's say I am doing, usually by the Adder-Subtractor, I do A plus B or A minus B. You agree? Where B could be any value and A could be any value. When you are working on adding or multiplying by a constant, it's going to be, let's say, A plus 5 is an example. A minus 3 is another example. So they are special cases where you create, by contraction, a smaller block. Okay, and we will create 2 cases in the homework. Okay, you might not know how to do it when I give you the homework, no problem. When I solve it in class for you, you will be able to solve. Okay, so try to solve it, but if it did not work for you, no problem. I will solve it in class in details. Okay, so we will create functional blocks by contraction, and we will do the one for the plus and one for the minus. Okay, so what I was saying is in the incrementer, you could do A plus 1 or B plus 4, and these are called incrementers, but you are adding up by a fixed value. Okay, so instead of having now a variable for the B, you will have a constant. So I already know, I'll give you the hint for it. Let's say you have A0, A1, and A2. Okay, so B is not going to be B0, B1, B2. Let's say I am adding 1, it's going to be 0, 0, 1. So what is B0, guys?
1.
We know that it is 1. So what is B1? It is 0. What is B2? It is 0. So I know their values. So I can actually create, by contraction, a smaller block, functional block. Okay. Of course, it also could be a decrementer. So A minus 1, B minus 4. I am subtracting by a fixed value. Okay. Clear? So here in this example, you have to use the formula for the full adder. Okay. In the example that you will do in the assignment, you will have to create the formula of the full adder, where the sum, if you remember, the sum is equal to A. Sum is equal to A XOR B XOR C. So if you are doing it for 1 at a time, it's going to be A0, B0, and the carry in. Clear? So now in this case, what is A0? So you replace S, it is A0. What is B0? 1.
1.
And what is the first carry? First carry. Would you have any carry?
0.
It's going to be 0.
0.
You have to know the formula where when you do A XOR 1, what does it give you?
1.
أيوة.
Yes. And now XOR it with a 0. What does it give you? It will be the same, right? So now S is equal to A bar 0. Okay? So this is what you will be using in the assignment to find, of course, this is S0. This is what you will be using in the assignment to find the value of S0 and C0 and S1, C1 and S2, C2. So you need these equations to find the formula for S and for the carry. Okay?